Okay.
Everybody should be called their siblings.
McKenna just clicked
Siblings
sarcastic.
names!
Yeah, siblings names. I'm Nikki.
Right.
Mr. Dude.
Pedro.
McKenna just.
Yeah.
You ready?
I just started it.
Okay, good.
Okay.
Alright, good.
So we're rolling.
So, if you remember what it is, I'm going to intro the topic. It's graphing rational expression. Oh my god, I meant to like color this in because it's expressions, but it's the only thing that's black.
You should say that on the video. And be
It's
like,
like- Yeah, we should when we start. We'll wait till we start.
Hey,
No. Yay! It's like fire. Ah. Okay, so today we'll be doing graphing rational expressions. Are you ready?
Yeah!
Are you ready?
Yeah!
Yay, math?
Yay!
Yay,
Yay!
It's like a chorus. Okay, cool. So, thank you for this. It's Friday. I feel good. Graphing rational expressions is really a tough. Wow, nice. It's really a tough topic. So we actually may spend 2 days filming this. So keep that in mind. That's the reason we pushed the quiz to Wednesday. So yeah, we did postpone the quiz because this is a challenging topic. So let's go through it piece by piece. If there's any questions on the way, just ask, all right? You all have your pretend names, so let's have fun with it. So the first thing on your paper...
I forgot mine.
I see that. Must be nice.
Oh yeah, Nikki.
Nikki, okay. This is a function, f of x equals, and we have a volunteer to read loudly the first bullet point, please. Okay, please, what's your name?
Scrabble.
Scrabble. Okay, Scrabble, please read nice and loud.
Because rational expressions are in the form of a fraction, the denominator of the fraction cannot be 0, or the function would be undefined.
Right, so the denominator can't be 0. The denominator can't be 0. Those of you with calculators available, if you have them, please do, let's say, 5 divided by 0. 5 divided by 0, what's the error?
Error.
Error.
Divide by
Undefined.
0.
Right, divide by 0. Right, you pick that up? So yeah, you can't divide by 0. So in other words, is there or are there values for x in which the denominator would be 0?
C.
Very good. It's like A, B, C. So what number would that be?
1.
1. So x can't be equal to 1. Okay? X can't be equal to 1. So that's an important thing. Can x be anything else?
Yeah.
Can x be equal to 0?
No.
Yes.
Oh yeah. X could be 0. For example, if x were 0, that would go 0 here and 0 minus 1. And so what's that?
X is 0.
Yeah, I'm saying if x is 0, this would be 0 here, 0 minus 1.
Negative.
It's 0 over negative 1, which is?
Zero.
0, right? So 0, 0 is on the graph. Alrighty? So that's that one. Let's do the next one. X equals 3 over x plus 5, x minus 3. Is there or are there, bless your soul, value or values of x in which this, or values that x can't be?
Yeah.
Yeah, do you see? 1 or 2 or none?
Well, it can't equal 0.
X could be 0.
Oh.
X,
The
no, I'm saying
denominator.
in total it can't equal
It
0.
can't
So
be
there,
3 or negative.
so there's those numbers.
Right, the numbers that the denominator can't be 0 is what you're implying.
Yeah.
And the denominator can't be 0. What's the values for x? The bottom, I heard it once.
3.
3
3
and
and negative 5. Any questions about that x can't be 3 and x can't be negative 5? All
That
right?
makes sense.
Very good. That's that one. And then we are over here, and we say f of x equals x plus 3 over x squared plus x minus 6. How do we figure out what the denominator can't be? We need to do what?
Factor.
We need to factor. Very good, guys. Can you factor for the bottom for us?
X plus 3, x minus 2.
X plus 3. Oops. X plus 3. X minus x minus 2. Like violently slamming
Can you
this mic.
cancel?
You would have to cancel in this case, right? So the real graph of what you're trying to do is this one, 1 over x minus 2. However, it still remains that x can't be what or what? Negative 3.
Or
2.
Or
oh,
2.
whoa, we crossed out x plus 3?
Can we cross out factors?
Yeah.
Yeah.
Right, but it still remains that x can't be negative 3 and x can't be 2. So
I don't
that's
understand why it can't be negative 3, though.
a very good question, because you see that they cancel, right? But we have to honor the original graph. And in the original graph,
X minus 3 would make it equal to
yeah, if we plugged in negative 3 here, we cancel because this is able to cancel.
I thought you
And
can't
if it's-
cancel
and
if there's
if it's-
addition.
Hold on. Let's answer a question because you have a good question too. We are able to cancel, so we do. So what really is being graphed is 1 over x minus 2. That's the graph that actually appears.
So then that's
However-
where the 2, x cannot equal 2 comes from.
Correct. So x still can't be equal to 2. However, according to the original graph, x can't be negative 3. And we'll even demonstrate. What's negative 3 squared? 9. Plus negative 3 is 6. Minus 6.
0.
So x can't be negative 3. Your question was, I thought we can't cancel with addition terms. You're right. We're actually canceling factors. So notice x plus 3 is a whole piece, and x plus 3 is a whole piece.
Instead of the equal sign.
So they, what?
Like, let's say the equal sign was a plus, then we couldn't cancel.
Oh no, I'm talking about this particular fraction can cancel x plus 3 over x plus 3. Okay? So that would be, but there's still restrictions. That's what we're getting at. Any questions on the idea of restrictions based on the denominator? Okay, so let's switch gears. Fast erasing. Do you guys watch the videos once they're posted?
Yeah.
You do?
Yeah, when I'm asking, I
If
watch
I
them.
can't remember what to do.
Okay, I'm glad. Good.
I know.
So, like, I don't.
What video?
Levity.
Is this one you're making? Oh, sorry.
Right on. What can't x be?
3, negative 3,
Good.
and negative
Good
Why don't
job.
we factor
Is
and
this
make
an
it
extra?
Why don't we factor and figure it out? Right. So if we were to factor this, we would get x plus 6 over x plus 3 and x, oops,
No, x minus.
X plus 1 and
x plus 1, x, yeah, x plus 2, x plus 1, right? I was thinking of a different one. Right. Okay, so there we are.
So it can't be negative 2 or negative 1?
So it's just the opposite of what's.
Actually, you know what, I want to take this down. And what I want you guys to do, yeah, it's setting it to 0. It's setting each factor to 0, just like we were solving. Okay, now here's the tough question, the first tough question of the day. If you guys would draw yourselves a little mini graph. Okay, draw yourselves a graph. And on your graph, please tell the class where x is equal to negative 2.
Oh my god. 2.
Where x is equal to negative 2. This is the x-axis right here, isn't it? So where is x equal to negative 2? Do I go right or left?
Left.
Left. 1, 2. So here x is equal to negative 2, right? What's this point?
Negative 2, 0.
Very good. Negative 2, 0. Great. Question remains. Can x be negative 2 somewhere else?
No.
Yeah, all down the
Something.
line.
Very, yeah.
All
Yeah.
down the line of negative 2.
So the line, what's the line? What type of shape did you just put your hand in?
Vertical.
Vertical, right. So you're saying that this is the point negative 2, for example, 1. Negative 2, 1. Negative 2, 2. Negative 2, 10. So in fact, how many points are there for x to be negative 2? An
Infinite.
infinite number of points. And where are those points? Where do they lie? They lie on this vertical line. So, may I ask you, well, you're probably going to say yes. So if I were to ask you, if I was going to graph something in green, if I was to graph something, would it ever cross over this line?
No.
Because, good job, because wouldn't it, if I graphed this, let's say a squiggle like that, that's not very dark.
Well,
Still not very dark. So the graph would touch this point. Suppose this point was like -2, -8. Is this point allowed to be on the graph?
No.
No, it's not.
No way.
Because we agree that x is not allowed to be -2 at any time.
Oh, gotcha.
Good, good. Love those moments. Asbestos.
Awkward math jokes.
What is asbestos?
It's like it's very poisonous, bad to breathe.
It's when like you make.
So let's make jokes about it.
Yeah. What does this have to do with math?
Have you seen the muffins video?
I haven't, but please tell me about it.
Oh,
after.
macaroni and
Thank you.
cheese.
So, are we comfortable with the idea that the graph can't go through this vertical line? Any questions about that, please?
What's the reason that we're making, like, I understand why x is not -2,
Right.
but what's the reason, like, why can't we have, like, an undefined, like, why can't we just have it, you know?
We are, but I'm saying in terms of graphing, within a graph, this vertical line represents every point where x is -2.
So, but
Right,
that,
right.
And if this line represents every point where x is -2,
Then no,
we
no point
recognize-
on our graph should hit that line.
Right.
Wait.
Yes, please.
My name is Potato.
Okay, potato, please.
So, okay, if you would.
I thought it was Eli.
No. Please, what's your question?
Okay, so when you would graph x equals -1, it would have to stay. The parabola would have to stay in between those two parameters.
Right, so the graph will have stuff inside those. So we're going to move to the next point. What is the next vertical line where the x or the graph can't touch?
Negative
Negative
The x
one.
equals -1, so I'm going to graph that
so
as
why
well.
are we grabbing them?
No, you graph them
So
in
he's
dotted
trying to
lines.
show
Very
us.
good question. These are invisible lines
Oh.
where we know that the graph can't touch. Are you familiar with the idea of magnets, north-south?
Yes.
Right? So north-north magnets, do they repel or attract?
Repel.
Repel, right? So think of these as magnets that repel. The graph may come very close. The graph will come incredibly close, you'll see. It'll like come,
It's like going
let's say
straight
the graph is approaching, I'll show you what it does. There's a lot to do. The graph may approach, and what do you think it'll do when it gets to
Go
this
up.
line? It'll go up.
Or down.
Or down, right.
But it'll never touch.
But it'll never touch, right? The term for the line in which the graph will never
Are there
touch,
2 lines or 1 line?
there are two.
So do we always have to graph those with dotted lines?
Yes, please do so. You
No.
always have to grab those.
Is it?
Yeah, you'll see it on your calculator as well. The term for the lines to which the graph can never touch are called asymptotes. It's already on your paper. Asymptotes. So I would call them like asymptotem poles or tater tots or tots for kids or
What's that?
turtle. Turtles. So those are asymptotes that are vertical. Next example. Let's take this off.
Algebraic, like, thing sounds like the name of, like, some disease.
F of x equals. It doesn't sound like a disease. That's terrible. It's awful. I got a case of asymptotes.
Exactly. Algebra. Like,
It's an itching disease.
I have algebra.
Algebra.
I've come down with algebra.
I got a case of the geometry.
No, I have algebra 1.
Algebra stage 1. All right, this one. It's tempting to say that the vertical. Stay with us. It's tempting to say that the vertical asymptote is where?
Oh, 1.
1.
Okay, so what would be the equation of that line?
Well, at bottom
X
it would be
equals
1.
one.
The top you have to actually set it to 0.
We will factor the top, correct. But don't you agree that the restrictions have to do with the denominator only?
Yeah.
The denominator only is the restriction. So it's
okay.
tempting to say that the vertical asymptote will be at the line x equals 1. It's
Wait.
tempting to say that.
Can you say that again, but slower?
Sure. It's tempting to say that the vertical line that we draw is at the line x equals 1.
Why? Why is
Because the graph can never touch x equals 1, because x is not allowed to be 1. So the graph will never touch this vertical line at x equals 1.
It's making my brain pudding.
Pudding.
I don't
It's brain pudding is actually a cure for a case of asymptotes.
What kind of pudding?
Potato pudding.
They don't actually do that, do they?
So stay with it, because this is challenging. Okay, I'm going to tell you in a second.
But
Remember
it'll be zero.
before?
It'll be zero, that's why.
No, remember before x couldn't be -2?
Yeah.
So we drew a line and x equals -2. Here, what can't x be?
Negative
1, positive 1.
Why?
Because 1 minus 1 is 0. So 1 minus 1 is 0.
Okay.
And if 1 minus 1 is 0, x can't be 1. So you're saying that it's tempting to say that the vertical asymptote will be here at x equals 1.
Yeah.
Right? But it's not, and I have to explain why. Question.
No, I think I know why.
All right, so why? Why?
Because x squared minus 1 is actually a difference of squares.
It is a difference of squares, meaning we do what?
X plus 1, x minus 1.
X plus 1, x
Alright,
minus
I
1.
forgot 1 squared is 1.
So you cancel.
That happens.
And it's x plus 1 over 0.
And then you cancel out
So
the
now we're going to cancel. Check it out. These go.
Yeah, but you said even if it cancels.
You're right. You're right. So I'm glad you remember that. So here, don't we have f of x equals what? X plus 1. Now, isn't f of x like saying y?
Y.
Yeah.
Right. So I'm going to write y
Equals x
equals x plus 1. Can anyone recall what type of graph this is?
It's a line.
Very good. It's a line. It's a line. It's a slanted line, right? Let's go ahead and graph this.
And it's a function.
I did it.
Good job, Maddie.
The cat is on fire. I mean, macaroni and cheese is on fire.
Funny. So how do you graph a line? Y equals mx plus b, starting where?
At the y-intercept.
Y-intercept of
1.
1.
Up 1. Correct.
I have really fun.
Apply slope, 1 over 1, as you know. So up 1 over 1, down 1. Okay, and I'm going to graph this line here.
Wait. Doing a dotted line now?
No, no, this is not. This is the graph. We just graphed this.
Right.
All right? Now here's the problem. The problem is we still have a restriction on x.
Okay.
What's the restriction on x?
There's a dotted line. There's an
Not necessarily. No, just tell me numerically. I'm glad you're saying that.
Okay.
What is the numerical restriction on x?
X cannot be.
Can't be
Negative 1.
positive 1.
Oh, 1.
Right on. X can't be positive 1. Can it?
You have to erase all of them.
No, good question. You don't have to erase all of it. You have to ask yourself, okay, well, that's my line. I know I'm graphing a line. However, is there a point on this line?
One to the left.
Sorry?
Anything past -1 to the left you can't have.
No, but x can't be positive 1. So let me phrase the question. If we acknowledge that this is the graph of a line, and we graph it, and we also acknowledge that x is not allowed to be 1, we ask ourselves, where on this red line is x equal to 1? Where on the red line is x equal to 1? Here, y is equal to 1.
At 2.
The next
Line is 2.
So 1 up, 1 over. So do you know what this point is?
1, 2.
1.
1, 2, very good.
But it's invisible.
So this is called a hole. This is called a hole.
And do you draw it with like a circle like that?
You do.
There's just like a
I
little
don't
like.
get it.
If you can please take your calculators out.
That's so cool.
Wait, I'm so confused.
In other words, I'll explain it one more time while people are taking their calculators out, and I want you to enter this in your calculators.
Will the hole show up?
What?
And the whole it'll be a gap, you'll see. Enter the numerator with parentheses, okay? Divided by the denominator with parentheses, very important. And you'll see, that'll even make this more pronounced, that there'll be a gap here. In other words, x is not allowed to be 1. So the line skips over the point 1. Okay? So it's probably an enter in your, or an error in entering.
Whoa.
Mine did not skip over the point 1.
Do
Mine
zoom
did.
4. Do zoom 4 to look at it. Zoom 4.
So what is the significance of that?
The significance is we know that we're graphing a line. However, the line omits the x value of 1. And that omission is called a hole.
There's like a tiny.
So give us a question.
Blueberry cream pie. Could you help Potato with her graph? So like a hole there. Cool. Hopefully you see it.
Yeah.
Okay.
X squared
Ready?
z x squared minus 1.
Okay.
That's cool, man. That's cool. Right, Apple?
All right. Let's keep going. Let's keep going.
This is difficult.
It's a lot of work. It's a lot of. There's a lot of terms.
Wait, I have a question.
You know, please.
We added the function, like, I think it was x squared, was it minus 1 over x?
Minus 1.
X minus 1?
Yeah, it was right
Then we
there.
found out that it was f of x equals x plus 1. Yeah.
Yes.
So those are interchangeable?
We're getting a syntax error over here.
Okay, we'll figure it out.
Those are interchangeable, correct?
You graph the second one, but you honor the first one.
Okay.
Yeah. You graph the line.
That's just weird because if they're equal
They are.
to
They
each
are.
other, they're different.
No, what it ends up becoming is what you really graph.
Because you add,
What it ends up becoming is what you
you
graph.
add like
However,
that.
you have to honor the fact that x can't be 1, even though it canceled.
Yes.
Okay. Now let's look at this. Let's look at this one.
Are we back on a page?
Second page.
You see the little hole?
I don't see 2 over x.
Middle of the
Yes, I
page.
do. Yes, I do.
Ratatouille, you blind.
Now, are there any restrictions on x?
Yeah.
Right. So, is there any cancellation going on here? No. So, will this be a hole like we saw last time, or will this be a vertical asymptote? It will be a vertical asymptote, so we can say vertical asymptote at, oops,
So that's how you grade it.
yeah, vertical asymptote at x equals what?
0.
0. And I'm going to graph that line,
So you can,
right?
you can have only one.
So the graph will not touch,
Can they see that in this video?
hopefully, well, you know,
Yeah.
graph a vertical line here. So now they hear it. So there is a set of rules regarding asymptotes. Vertical asymptotes are pretty straightforward. They have to do with the denominator, right? You look at all values for the denominator, which are 0, and then you recognize where to graph them. Except if they cancel, which we did in the last problem. If they cancel, they are no longer vertical asymptotes. What are they called?
Holes.
They're called holes.
I have a question.
I'll say it again.
Hole in the graph.
Vertical asymptotes occur when the denominator is 0. Yeah. Except if those factors cancel, like we did in the last problem.
And it becomes a line, and therefore there are holes in the line.
Many times it'll become a
Point
hole if
this
it cancels.
comes to
I have a question.
Yeah,
If you
that's
plug it into your calculator and you go to the table,
Mhm.
how will you know which one's a hole? If it's a hole.
Where it says error. So if you still have it on your calculator, you can see the value for x equals 1 will be an error. Good, I'm glad. Okay? Now we have to talk about horizontal asymptotes. Horizontal asymptotes is more
What
challenging.
would the graph look like? When you graph it, would just be up 2 to the right 1, up 2 to the right 1. Just
No,
make
no,
there be
it's
a hole
not.
on 0.
No, it's a good question. It's a good question. We're going to get to that. So vertical asymptotes. No, we're done at what time? 50?
50.
Ah! Okay, so why don't we pick up horizontal asymptotes on the next lesson, all right?
Okay.
So I'll pick it on that. All right, everyone, say bye. Bye. Everyone say bye.
For next time.
Bye. Bye.
Jamie.
Bye, math.
Mr. Dude, do you hear
What's the first step in factoring?
Yeah.
Math.